Okay. Well, first off, just so I don't forget, our midterm will be a week from today, next Wednesday. We'll talk more about that on probably Monday. In turn, I usually go through the slides and say this is what you should focus on, yada yada yada. But it'll be my usual tests, 10 questions, each one worth 10 points. No multiple choice, no fill in the blank. It'll all be like short answer, some programming, some explain to me what this keyword does or how this and super are different, that kind of stuff. But we'll talk about that in more details. But because I think next Friday is the last class before spring break, right? Yeah, so we'll have the test on Wednesday. We'll go over it on Friday. So I'll have it graded in there, and then we'll come back after break. And I don't know if we'll immediately start with Unity, but we'll be starting to transition towards our other tool after we cover a few more things here on the Java side. Okie dokie. So homework for today was to create a, let's see, inside of player, we have a new command called throw, right? And the idea is we're trying to teach our monsters how to move from one room to another. And as of right now, we're forcing the issue by having the parent or having the player actually toss the monster from one room to the next room. Okay. So when we type in throw right now, we're asking the player some information. We're saying, okay, well, who do you want to throw? That's going to be the name of the monster that you want to throw. Where do you want to throw it? So what direction? And then we're just kind of giving a warning right now, like, we're about to throw the rat to the north, something like that. All right. So what we need to add in here is the actual stuff to throw it. Okay. So maybe we put another little print statement here. Has been thrown. Something like that. All right, so we have to build the logic in here that actually does the throwing. All right, so what does it mean to throw the monster? Well, first of all, we need to acquire the monster from the current room, right? Now, from a player's perspective, the player can only throw a monster from within the room they're currently standing in. So the player already knows about their current room, right? The player's current room is stored inside of this dot current room. Okay. Now, a room has a couple of array lists. Well, one of their array lists is a collection of monsters. We decided last time that a room would still know about its single player, and then it would have a separate collection of monsters that are in the room. So we're going to have to go through and find let's say the first monster with that name inside of my collection of monsters in a room. Okay. So let's teach a room how to get a monster given its name. We already have a couple of other things. Don't we have a get and exit? Or we put that right into exit. That's fine. All right. So we're going to teach a room here. So public, and this guy's going to return a monster. Because ultimately we want to say, here, I want rat. give me the monster object that is the rat. All right, that's what we're trying to accomplish. So we're going to teach a room how to do that. So it's going to return monster. So get monster given name. And this will take in a string name as a parameter. All right. So now what we want to do is we want to now loop through all of the monsters that are in this room. So we're going to go through this list of the monsters. So for int I is equal to 0, I is less than this dot the monsters dot size I plus plus. So this loop will go through our collection of monsters. And then we want to get the monster that, so we can say something like monster temp is equal to this dot the monsters dot get it bucket I. So we'll just go ahead and grab the current monster that we're looking at. And then we want to know, does this monster have a name that matches this name? Okay, now I'm inside of room here. All inhabitants, both players and monsters, have a name, and that name is protected. So it only is accessible inside the inhabitant class and children of the inhabitant class. Room is not a child of the inhabitant class. So what we're going to do is we're going to teach all inhabitants how to return whether or not they have a certain name. So we're going to say, whether you're a player or whether you're a monster, we're going to say all inhabitants can say, yes, that's my name, or no, that's not my name. We actually already have a get name. What I was going to say is we can have a function that returns a Boolean called has name. But we already have a get name, so we can just ask the monster for their name and then compare it. So we'll say if temp dot get name, which is going to be the name of the monster, dot equals the name we're looking for. If that's a true statement, return temp. I found the monster called, in our case here, in our example, called rat. Okay. And in this particular thing, let's say we have a room with 5 rats in it. This would return the first rat it found. All right. So if you don't have unique monster names, you just have a room filled with rats. It'll just grab one of them. It'll, in this case specifically, it'll grab the very first one. Okay. Now, if I've gone through the entire list of monsters and I don't find a monster with that name, then I could return null, saying, hey, I didn't find any monster. I could throw a runtime exception. This might actually be a good place to throw a real exception. So I didn't necessarily expect you to do this on the homework, but what I'll do is I'm going to say that get monster throws an exception. I won't invent a new kind of exception. We'll just keep it as a generic exception. And you'll see how I'm going to use this here in a second. So we'll go ahead and say, if I'm here, I am here, I did not find a monster with that name. I'm going to go ahead and throw a new exception. And you give the name of the exception. So we're going to say monster with name not found, something like that. So that's the exception we will we'll throw there. All right. So we will try to ask a room to hand us the monster object given the name of the monster. But since this guy throws an exception, we will have to try to do that and catch an exception that might occur. So this is kind of how error checking might work for this. rather than us having to check to see if this guy returned a null value before we continue on. So inside of player, if we are in our code for throw, we're going to try to do some stuff. We're going to try to get the monster from our current room, calling the get monster given name, passing it the name of the who we want to throw, which should be the name of our monster. But we're going to try to do this. And we're going to potentially catch an exception E, and then we can do something like system.err.println. I'll just say E. We could also do something called e.print stack trace. Doesn't matter. It'll just show us an error message, but more importantly, our program won't crash. It'll just keep going on. I'm going to move this line inside my try. All right, so we're going to try to do some stuff. And if anything goes wrong in here, rather than the program crashing, we will catch whatever exception gets thrown and we'll just print out that error message. So at that point in time, no throwing actually occurs. This loop will just end. It'll spin back up and say, what do you want to do? Right? You could try to throw again if you mistype the name or something like that, but you know, program's still kicking. All right, so presumably, if I didn't throw an exception on this line, I have an actual monster. And now I want to get that monster out of the current room and put that monster into a room in a certain direction. So let's see what rooms have. So we can ask a room whether they have a certain exit. We've done this before with our player, right? So we can then say, if this dot current room dot has exit, where? So if they have a exit with direction where, so we have the who and we have the where. Who is the monster we want to throw? Where is the direction we want to throw them? So I'm asking my current room, because remember I'm in player. So from the player's perspective, does my current room have an exit called where? If yes, then I want to take that exit. So here is our take exit, which takes a string direction, but notice what this guy has in it. It's going to call it's going to go through all the exits in a room, and it's going to find the exit leading away from the current room. So the correct exit. But then what it's going to do is it's going to send the current player in that direction. We need to send a monster in that direction, right? Not the current player. So what we can do is we can write a different version of take exit. Public void take exit string direction monster the monster. Something like that. We have two methods with the same name, but a different number and or type of parameter. What's that called again? Polymorphism. All right, so I'm going to write a different version of take exit here. I'm going to do something here. Let me just steal most of this code. So I still want to find the same exit, right? All right, so I'm going to go through all my exits. I'll grab the current exit. I'll ask if the current exit has a string leading away from this particular room in a certain direction. If they do, then I want to take that exit in a certain direction. And actually, this could be handy for us. Let me look at exits travel in a direction. That guy takes a player as a parameter, but we can fix that. But that talks about a room's player, because remove player is going to be different than remove monster, because we have those guys in two separate categories. That's okay. So we'll just write a separate version of this. More polymorphism practice. So we have two versions of take exit. This one takes a direction and a monster. We're going to loop through. We're going to ask the room, do you have an exit leading in a direction away from me? Assuming that this room has that exit, then we want to take that exit, but we want to do it with a monster. Okay, so we're going to teach exits how to travel in a certain direction with a monster. Okay, so a monster is going to travel in this certain direction, coming from a room. All right, and we're going to have fairly similar code in here. So we're going to say if the direction we want to travel is in the direction leading to destination 1, we're actually going to go to destination 1. But instead of setting the player to destination 1, we're going to set the monster. Set room and remove player. Does inhabitant have set room? I believe they do. They do. So actually, we don't need a second version of travel and direction. Instead, we just need an inhabitant being passed in here. And instead of calling this guy the player, we'll call it the inhabitant, which might be a player, but might also be a monster. Could be either one of those two, right? So, steal this word. So if we're going in this direction, we're going to set the inhabitants room equal to this destination. Now, from room, we're saying remove player. That's where it's going to get sketch. That's okay. So we're going to teach a room. A room currently knows how to remove a player. Remove player. And this guy specifically modifies the current player variable. I'm going to teach this guy how to remove a monster. Okay, so we're going to teach a room, how do you remove a monster given a monster? Now, we can do this several different ways. You could have gone and looked at the documentation for array list and seen that there's a remove function where you can pass it a pointer and it'll remove of that value. So I can either remove something at a particular index. So I could write a loop that goes through and says, are you the monster I want to remove? Are you the monster I want to remove? Are you the monster I want to remove over and over and over again? And as soon as I find it at bucket 7, I'll say remove bucket 7. Done. Monster's gone. He's out of that. He's out of the current room. Or I can say, hey, I want to remove a certain object. This removes the first occurrence of the specified element from the list, but only if it's present. Presumably, we wouldn't be here if it wasn't present. So I'm going to say this, I'm in a room, so this is this instance of room. The monsters dot remove the monster. So this will ask the current array list to remove this guy from it. And it'll go through, it'll find that memory address and get rid of it. Now it's not getting rid of the memory address, it's just taking it out of the array list. All right, so from a room's perspective, after we call remove monster, that monster is no longer in that room. He's currently in limbo until we put him into another room. Make sense? So while we're here, why don't we also teach a room how to add a monster to it? We actually should already have that, don't we? Yeah, we have an add monster. So room already knows how to add a monster to this, and we can set we set that monster's room all within that same thing. So back here in player, if the current room we're in has an exit called where, we want to remove this monster from that room. And we just taught a room how to remove a monster. So we're going to remove a monster from the current room. Which monster? The monster. So we'll say the monster. I'm sorry. I'm in player. So this dot current room dot remove monster, the monster. So from the player's perspective, he's going to take his current room. He's going to ask that room to remove the monster. Which monster? This guy right here, this instance of the monster object, which a room now knows how to do. So after this line, the monster is no longer in the current room, but they're also not in the destination room, right? So now what we want to do is we want to actually take an exit. We've already asked if it has the exit. We've asked a room, do you have a certain exit? Next, we want to do is we want to take this exit. Now, a room is taking the exit with the current player. So we're traveling in a certain direction from a player's perspective. Again, we're dealing with inhabitants here. So let's go and look at exit. And let's look at travel in a certain direction. We were looking at this a few minutes ago. So this is now a guy who takes an inhabitant as a parameter and is going to remove the player from a certain room. We can actually do the travel in a direction. We can do it all in here if we want, because it doesn't necessarily matter. So travel in a direction now knows how to work with generic inhabitants. But in here, when we work with this inhabitant, we can always set the inhabitant's room to this new destination. That's always okay. But we only want to remove a player if the inhabitant is a player. How do we ask whether or not this variable is a player versus whether that guy is a monster? Do we have a way of asking if an object is an instance of a certain class? How do we do it? Instance of. All right, so I'm going to say if the inhabitant is an instance of player, then I'll do that. Else must be a monster, right? Must be a monster because we only have players and monsters right now. We're not going to get significantly more complex than that in our game. So must be a monster. So what do? We've taught a room how to remove a monster. From room dot remove monster, and the monster that we're going to remove is the inhabitant. That was past it. Okay, so that'll remove that monster from the room. Similarly, we're only going to add the player to our destination if it's a player. And remember, our destination 1 is another room. Rooms have ability to also add a monster. So if I'm dealing with a player, remove the player and add the player. If I'm dealing with a monster, remove the monster. Let's go there. And add the monster. Now, remember, we're not dealing with a variable called the player anymore. Now we're dealing with some kind of inhabitant, either a player or a monster. So if the inhabitant happened to be a player, we'll treat it as a player. Remove the player from the current room, add to our destination 1 that player. Otherwise, if it's a monster, we'll remove the monster from the room, and then we'll add to destination 1 that monster. Make sense? Whether it's a player or a monster, we can just tell the inhabitant to go ahead and set its room to the destination room, because inhabitants all have a current room. We put that as a common ability inside of inhabitant. Let's go ahead and steal that code here. We'll put this into the else if. And in this case, we're just dealing with destination 2 instead of destination 1. All right, so now travel in a direction takes in an inhabitant instead of a player. We've updated that guy's ability for exit. So now we can throw anything we want through that door, players or monsters. Okay. Who calls travel and direction? That's going to be rooms take exit. Here's take exit. We're going to go through here. We're going to find an exit. We're going to say, hey, does this exit have a room in a certain direction? If it does, right now we're saying travel in a direction, but we're assuming take exit always takes in the current player. Because take exit right now does not take in as a parameter who is taking the exit. So we can say inhabitant, the inhabitant I just like naming my variables like the player, the monster, the inhabitant. So who are we traveling in that direction? Whoever the inhabitant is, not necessarily the player. Make sense? So when I'm talking to the current room and I say, okay, time to take the exit, I'll let the room know who is taking that exit. So back in player here, we need to update our else. This guy down here, when we actually take the exit, this is the else when a player is taking the exit. So the player is going to say, I'm going to walk through that door. They're talking to the exit. Well, they're talking to the room and saying, hey, I want to take one of your exits. So here's the direction I want to go. And it's me that's going to be walking through that door. Because we just updated take exit to now take two parameters, the direction and the inhabitant that will be moving in that direction. Similarly, up here with our monster, after we remove a monster from a current room, let me just confirm that take exit doesn't also remove them. Travel in a direction. It does remove them from that current room. So we actually don't need to remove them first. We can do everything with take exit. So right here, we're going to say take exit where and the monster. And this one function will remove that monster from the current room and put him into the next room. But we're only going to ever get to these lines if the room we were currently in had the monster. Because if it didn't, we would have thrown an exception and we would be chilling in here, writing our output monster not found, and then looping back around saying, what do you want to do now? You know, we could do something like if there was an error, we could have it go ahead and look around again. Just as a reminder, this is what the room looks like. Okay, because you said you wanted to remove the elephant from the room or throw the elephant from the room. No elephants here. Okay, so walking through this one more time. If the player says throw, we're going to say, who do I want to throw? This is going to be a monster name. Where am I going to throw it? That's going to be a direction. We're going to just warn everybody in the room that we're about to do some throwing. Then we're going to try to do the throwing. So first of all, we're going to get the monster from the room, assuming that's really the guy we have to try. I'm trying to do all that stuff, but he's the one that could be a stumbling block for us, right? So we'll try to get the monster. Then we'll ask. So assuming we have the monster, we will ask, hey, current room, do you have an exit in the direction I want to throw this dude? If he doesn't, we're not going to do any throwing, right? But if he has that exit, we'll go ahead and take that exit and then probably do something like that. And maybe if we want to add some comic relief in here. Bounces off the where wall or something like that. So if you try to throw him to the south and there's not an exit to the south, it'll say the rat bounces off the southern wall or the south wall, something like that, because there wasn't a door there. You got the rat, And you threw him, but he's still hanging out in the room. He's kind of ticked now, but he's hanging out in the room still. All right. So if this room does have an exit in the where direction, then we'll take that exit. And the who is taking the exit is going to be the monster. That is the inhabitant that is coming in to take exit in a certain direction. And when we find the correct exit, we will tell that exit to travel in a certain direction. Which direction? This guy. And who's traveling in that direction? We got to look at exit here. Travel in direction. This guy right here takes in a direction, takes in a room we're leaving from, and takes the inhabitant that's leaving. Here's the direction. This is the room we're leaving from. And this is who is leaving, either a player or a monster. So we've made this guy more generic. He works for both players and monsters now. So that will take this exit by traveling in a certain direction, where if we're a player, we'll remove the player from the from room and add the player to the destination room. Otherwise, we must be a monster. We'll remove the monster from the from room and add the monster to the destination room. But all that only happens if we had a monster and the room has an exit. If the room doesn't have that exit, but we did have a monster, we'll go ahead and spit out, hey, you bounced him off the wall. All right, so let's go ahead and run this dude. Okay, we've got to play. Oh, so add player. It's a player. I'm calling add player. Oh, technically, this guy is a generic inhabitant right now, even though an inhabitant is a player. So I'd say treat this dude as a player. Similarly, treat this dude as a player. And we're going to have a very similar error, I suspect, for the remove monster. Yep. So we're going to say up here, treat this guy as a monster instead of a generic inhabitant. Treat that guy as a monster. Treat this guy as a monster. Monster, player, monster, player. Okay, so we'll go ahead and say throw, and then who do you want to throw? We'll say rat. Where do you want to throw them? We'll say to the north. About to throw, rat through the exit to the north. Rat has been thrown to the north. If I say look now, I don't see a rat here anymore. I move to the north and we don't see a rat in that room. So the rat did not get added to the final room. So that's from our take exit. So we tell our room to take the exit. Here's our room, take the exit. Here's the inhabitant we're taking, and we should have the correct inhabitant. It's the monster. Okay, great. Then we have, so this guy takes the exit. Exit comes in here. That's a room that takes the exit. We go through here. We ask, does we find the exit that has a room leading away from this? We travel in that direction, passing the inhabitant that was passed in. That guy is coming through an exit, travel in a direction. So the only thing I can think of here is that our monster isn't the actual monster we think it is. That this dude right here isn't the guy we think he actually is when we say get monster from a room. We're not throwing the exception. Okay, well, I think everything I explained is accurate. I'll look at this for a minute and make sure that I don't have a bug here. But this should get the player out or the monster out of the current room and put him in the next room. Right now, we're successfully getting him out of the current room and tossing him into limbo. On Friday, we will take a look at threads because we want monsters to be able to move around on their own. Okay, questions, comments, concerns, bribes. And I'll look at this right now for a few minutes and then post a link to the code. I'll even keep the recording running in case you're interested in it. I don't think it's going to take very long to see what's going on. All right, so let's make sure we actually found the monster. Row, rat, north. Okay, thinks it found the monster. Take care. We'll just throw the memory address out here real quick. Oh, I called it temp. Row, rat, north. Okay, that's an actual monster. Great. So we'll get the monster with that name. We now have that monster. So that part seems good. So we now have a monster. Then we're going to ask the current room if they have an exit. We've seen that work before, so I don't think we have a problem there. Then we're going to tell the current room to take that exit in a certain direction with the monster. So this is something we've updated. So we have room. And we have take exit. Takes in a direction, takes in a monster. We're going to go through all of our exits. We're going to grab an exit. If that exit has a direction leading away from the room, we've tested that. So that didn't change. So that should work. Then we'll tell the exit to travel in a certain direction. It's not the current player. It's the monster. That's our bug. And actually right now we have, yeah, that's our bug. I was removing the player from the room. Actually, what's interesting is I actually moved north twice because I was in a new room because when I told when I tried to throw the rat, I actually threw myself through the door. So I was actually one room to the north, and then that was another room to the north when I moved to the north. So throw rat north. Okay, so if I look right now, I should not see the rat. If I move to the north, now I do see the rat. All right. So yeah, as we updated our take exit, because we have two versions of take exit here. Although we have the inhabitant version of this, right? Yeah, see, I think I wrote this one and I meant to write the inhabitant one because now it's this guy. It's defaulting to the one that takes a monster because I actually am throwing a monster. So I can actually get rid of this guy. I have two versions of it that effectively are doing the same thing. I must have been in the middle of explaining polymorphism or something and then decided I was going to change it. So now take exit takes in an inhabitant and we're going to travel in a direction with that inhabitant. So it should still work. Now it's just always going to call that version of it. So throw rat north. We'll move to the north. We see the rat there. I'll throw rat. I'll throw again. Rat. And I'm going to say north again. There is no thing north. So now he's going to say rat bounces off north wall. I'll throw elephant. Say west. Here's the exception, monster with elephant not found. I probably should have said monster with name, elephant not found. But notice here, that's our exception, but the program still runs. It didn't crash. Okay. So actually, we didn't have a bug in what we actually wrote. We had a bug in the leftover thing after we realized we made a more generic thing.